Here we can see one more problem. The decimal expansion of the rational number 43 by 2 to the power 4 into 5 to the power 3 will terminate after how many places of decimal. So it's a very easiest problem. If you read the problem, what they're asking, how many places of decimal it will terminate. So we have 43 by 2 to the power 4 into 5 to the power 3 is equal to 43 into 5 2 to the power 4 into 5 to the power 4. So we can write this as we are multiplying both the term as 5 to the power 5 into 5, then both numerator and denominator, then 43 into 5 2 to the power 4 is there. We have to make them as same number. The denominator should be equal to 10. So multiply the denominator with 5 to the power 4. 215 into 10 to the power 4 is equal to 215 by 10,000. So if we express it as decimal form, then it will terminate after 4 places, 1 2 3 4. Okay student, so like this we can solve so many problems regarding. We can see one more problem like this. Express 0.6. So can you see student? Express 0.6 has a 0.6 as rational number in simplest form. This one you learnt in your 9th standard also. So how to solve this problem is the very easiest problem. We have to call it as the given number as x is equal to 0.6 bar. 6 bar means here they are putting bar on the number 6. That means this number is repeating one digit. If on one digit they are putting bar, that's why the number only one digit will be repeating. Then x is equal to 0.6666. Call it as x equation number 1. Here one digit is repeating. That's why we have to multiply by 10. So both LHS and RHS. If you multiply both the side by 10, what happens? X will become 10x, so 0.66 will become 6.666. So on subtracting 1 from 2, 10x minus x is equal to 6.666 minus 0.66. And subtracting 6.6 minus 0.6, you will get a 6. So we want to find out x. X is equal to 6 by 9. Therefore, x is equal to 2.3. 0.6 is equal to 2.3. It is the simplest form of the equation. Very easy. You can understand. This one you already solved in your, you learnt in your 9th standard maths. Rational number, first unit only. Like that, any number they can give, you can solve. Then finally, I'll explain the last problem. Then you can understand very well. Okay student, let us discuss one more problem. Write rational number between root 2 and root 3. We know that the value of root 2 is 1.44 and the value of root 3 is 1.73. So we have to take in between the numbers should be present in between these two numbers. So we can take easily 1.4 and 1.5. It's nothing but 1.4 after in between the number I have to take. Clearly we can take 1.5. So 1.6 also take, any number you can take, find the rational number. They are not asking if they ask two numbers, find the rational number, two rational numbers, three rational numbers. If they ask anything, you can take any two numbers. That one you can do it. For example, you can take 1.6. 1.6 if you take 16 by 10, it will be 2 8s, 2 5s. So then 8 by 5. Like that, any number you can take. 1 by I took here 1.5, 15 by 10 expressed in a fraction form is equal to 3 by 2 is a rational number between root 2 and root 3. Root 2 and root 3 are also so many infinite rational numbers will be present in between these two numbers. So how to find out means we have to find out the square root in between numbers we have to take. Like that, another one problem, show that 3 root 5 is irrational. How to prove this one? Irrational. We know that 3 root 5 is a rational number. Then 3 root 5 is rational. 1 by 3 is a rational factor. Okay. So you have to take, if 3 root by is rational, then we have to take 1 by 3 is rational. So which implies 1 by 3 into 3 root 5. So if you take again the same number, you will get. Why we have to multiply 1 by 3 means the product of two rational is rational number only. How means you can say 3 root 5 multiply by 1 by 3. 3 gets cancelled. Again you will be getting root 5 only. That's why let 3 root 5 is a rational, then 1 by 3 is also a rational, which implies that 1 by 3 into 3 root 5 is a rational. We have to find out the product. What happens then? 3 gets cancelled, which implies root 5. Root 5 is rational. So which implies root 5 is rational. This contradicts that. This contradicts that root 5 is a rational. Root 5 is a rational. If root 5 is a rational, hence we can say that 3 root 5 is irrational. It's a very very easy problem. You have to keep in your mind also. 3 root 5 also irrational. The same thing if they ask find out which implies therefore, hence we can say that 3 root 5 is irrational. Okay student, like that we can prove. I'll explain once again. Show that 3 root 5 is irrational. How to show 3 root 5 is irrational? If they given for example another problem, find out 3 root 5, then what you have to do? Multiply with 1 by 2. 2 gets cancelled, we'll get a root 5. Any number they can ask. They can ask 6 root 2. Then what you have to do? You have to take the numbers, multiply by 1 by 6. 1 by 6 we have to take a assumption of rational number. Why means if you multiply means 6 gets cancelled, we will get a root 2 number. The rational number we should get. Okay. So irrational form we have to take now. That's why we have to multiply with that. Then that rational number we have to take. Show that 3 root 5 is irrational. So let 3 root 5 be rational. If it is a rational, then 3 root 5 is rational. We have to assume it's a rational number. Then 3 root 5 is rational and 1 by 3 is rational factor. So which implies that 1 by 3 into 3 root 5, 3 gets cancelled. It is a rational. Therefore, product of two number is rational, which implies 3 gets cancelled, root 5 is rational. This contradicts that root 5 is irrational. Hence, 3 root 5 is a irrational number. We can say like this. Like so many problems they'll ask in this chapter. Once again, we have to revise the points, whatever the content we learn in this chapter. So then we have to complete the chapter. So we are at the end of the completion of the chapter. So whatever the points we learn, so summary of this chapter, what is the summary of this chapter? We have to learn Euclid's division lemma, right children? We learned Euclid's division lemma, Euclid's division algorithm, fundamental theorem of arithmetic, and non-terminating decimal expansion, and non-terminating, non-repeating rational numbers. Is it right? What we learned the first point, Euclid's. Let's once again glance the point. Glance at points. Euclid's division lemma. Given positive integers a and b, there exists whole numbers q and r, satisfying a is equal to bq plus r is always greater than b, r is always greater than 0 and less than b. And another, Euclid's division algorithm. According to this, we find that HCF of two positive integer a and b, where a greater than b, by applying steps we will know that and the fundamental theorem of arithmetic. Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factor occur. If p is a prime and p divides a square, then p divides a also. That is a positive integer. To prove that root 2, root 3, root 5, root 6, root 7, etc. are irrational, they are asked to prove root 2, root 3, root 5, 2 root 5, 3 root 5, everything is a rational number. Like this problem in this chapter will come. And let x be a rational number, we can express as a terminating decimal by putting the numbers non-negative integer. So again we can come to conclusion. Let x be a rational number which can be expressed as a terminating decimal it should be in the simplest form P by Q. Is it right? If we put it is in the simplest form, that is already we solved in the last classes, that is in the form of 2 power m. Is it right? That is in the form of 2 power m into 5 power n for all some non-negative integers. See, this is the very important form. That should be non-negative, and that is in the form of 2 power m into 5 power n. Okay. So let x be a rational number. If it is a rational number, we have to express in the simplest form P by Q. The P by Q, it is in the form of 2 power m into 5 power n. Some non-negative integrals mandatory. So next, let x is equal to P by Q be a rational number such that where Q does not equal to 2 power m into 5 power n, then we can say that it is a non-terminating repeating decimal expansion. When x is equal to P by Q, but this P by Q is not equal to 2 power m into 5 power n, then we can say that x has a non-terminating repeating decimal. A number which can be expressed as a non-terminating, non-repeating decimal such that decimal is an irrational number. Those number can be expressed as a non-terminating or non-repeating. So if it is a non-terminating and non-repeating is known as irrational numbers. Example, root 2, root 3, root 5. They are asking in the exam, find out, show that root 5 is a irrational number, root 3 is a irrational number. To prove that root 2, root 5, root 6 are irrational numbers. So this is the very most important points on this chapter. Have you understood, student? A number which can be expressed as a non-terminating and non-repeating decimal is an irrational numbers. This is about your first unit, real numbers. Real numbers means is the set of rational numbers and irrational numbers. Real numbers is nothing but it is the set of rational numbers and irrational numbers. So, and fundamental theorem for arithmetic means that one also will learn. Every composite number can be expressed as a product of prime numbers, and only we can expect the order in which they return. That means HCF or GCD of two numbers, where the LCM is the least common. HCF into LCM is equal to A into B. That is also we learnt. Totally we have to understand every rational number can be expressed. Every rational number can be expressed in decimal form, which is either terminating or non-terminating repeating decimal. Have you understood point? Very most important point. Every rational number can be expressed in decimal form, which is either terminating or non-terminating repeating. If P by Q is a rational number, then Q can be expressed as 2 to the power m into 5 to the power n for non-negative integers. Then it will be a terminating decimal expansion. If Q can't be expressed, it cannot be expressed in the form 2 to the power m into 5 to the power n. Then we can say that the given P by Q will be non-terminating repeating decimal. The numbers which are not rationals are called irrational numbers. Example, root 2, root 3, root 5, root 6, etc. They are the numbers, they are not in rational numbers. So they are non-terminating and non-repeating numbers. It's a very easiest chapter. Students making mistakes mainly. Students generally don't bring given rational numbers in simplest form. Therefore, they are concluding wrongly. So, what is the remedial measures they have to take? If there is a factor other than 2 or 5 in the denominator, check whether it can be cancelled or not. That is also we have to keep in your mind. Okay, students. So, this is about your first chapter, real numbers. And also you have to keep one of the most important point. You should commit to memory that HCF into LCM is equal to product of numbers, valid for two numbers only. But what they are doing, students are making mistakes. They generate the result HCF into LCM is equal to product of numbers. So that's why we have to keep in your mind. We have to memorize that HCF into LCM is equal to product of numbers valid for any two numbers. So it's we are almost I covered all the types of problems. We have to revise in your mind very important concept. The very most important concept this chapter is Euclid's algorithm and lemma. Okay students, based on this we have to solve the problems. Four exercises are given. We have to practice that problem. If you have any problem you can ask me. If you have any doubt you can clarify. But in the on the examination basis, the very most important problem in this chapter they are asking, prove that root 2 is a rational number, 1 by root 2 is a rational number, 1 by root 7 or root 11 is a rational number, are expressed as a terminating decimal or expressed as a non-terminating decimal. Okay students, thank you. See you in the next class.